Compressed air energy storage. Energy storage part 2 for storing intermittent electrical energy. Introduction. The effective utilization of intermittent and variable energy source requires energy storage. Energy can be stored in various forms. In this lecture, we are going to discuss compressed air energy storage. Compressed air energy storage. Compressed air energy storage (CAES) is a technology in which energy is stored in the form of compressed air in an underground cavern. Air is compressed during off-peak periods, stored in a cavern, and then used on demand during peak periods to generate power with a turbo generation system. A typical CAES unit consists of 5 basic components. First, compressor train, including compressor, intercoolers and aftercoolers. About intercoolers and aftercoolers, we have talked about in earlier lectures. Second is motor cum generator. Third is turbine expander train, including expanders and combustors. Fourth is recuperators, and fifth, underground cavern. Compression of the air is powered by a motor that uses off-peak electricity from the grid. During peak hours, the compressed air from the cavern is extracted and preheated in the recuperator. Once heated, the air is mixed with oil or gas, which is burned in the combustor. The hot gas is expanded in the turbine to generate electricity. During the power generation, that is storage discharge mode of operation, the heat rate for CAES system is very low because no power is required for compression. Request. It is hoped that this session is going to be useful to you. Please press like. Please subscribe. Charging ratio. An important performance parameter for a CAES system is the charging ratio, which is defined as the ratio of the electrical energy required to charge the storage versus the electrical energy generated during discharge. The number of kWh input in charging to produce 1 kWh output. A low charging ratio results in low off-peak electrical energy requirements during the charging cycle. Fast startup. Fast startup is another advantage of CAES. A CAES plant can provide a startup time of about 9 minutes for an emergency start and about 12 minutes under normal conditions. By comparison, combustion turbine peaking plant typically require 20 to 30 minutes for a normal startup. Underground cavern. A significant contributor to the cost of a CAES plant is the construction of the underground cavern. Three types of geological formations used for compressed air storage are salt dome, aquifer, and rock caverns. Application of these storage media are illustrated in the figure shown in the next slide. Compressed air energy storage CAES cavern designs. Underground cavern. In addition to the geological formation classifications, there are two classes of cavern design concepts. Constant volume, also called uncompensated, and constant pressure, also called compensated. Constant volume cavern. In a constant volume cavern, the air pressure is allowed to drop as air is withdrawn from the storage. Constant pressure cavern. In a constant pressure cavern, water from a surface reservoir displaces the compressed air to maintain constant pressure in the cavern. Hunt-Orf plant. The first commercial scale CAES plant in the world is the 290 megawatt Hunt-Orf, Germany plant operated by Nordwest Deutsche Kraftwerk since 1978. The Hunt-Orf plant runs on a daily cycle in which it charges the air storage for 8 hours and provides plant generation for 2 hours. The plant has reported high availability at 86% and a starting reliability of 98%. The Hunt-Orf plant has a salt cavern. Macintosh plant. A commercial scale CAES plant was built by the Alabama Electric Cooperative Incorporated in Macintosh, Alabama, McConsey. This plant has the maximum existing CAES cavern capacity of 19 million cubic foot. It began operation in 1991 and provides 110 megawatt of power generation. The cavern for the Macintosh plant was mined from a salt dome by dissolving salt with fresh water. This is the schematic diagram of Macintosh plant. The cavern, which is 230 feet in diameter, 1000 feet tall and 1500 feet below grade, supplies compressed air supporting generation of 100 megawatt for 26 hours. The CAES plant has a full load net plant heat rate of 4568 BTU per kilowatt hour with a charging ratio of 0.82 at 25 megawatt. The performance is significantly reduced with a heat rate of 5253 BTU per kilowatt hour and a charging ratio of 1.3. A schematic of the Macintosh plant is shown in the attached figure. The Macintosh facility has high pressure, intermediate pressure, and low pressure compressors. Expanders, a motor generator, and high and low pressure expanders. Clutches, the compressor and expanders are connected to the motor generator by clutches. These clutches are used to decouple the compressors during the generation cycle and to decouple the expanders during the compression cycle. Request: it is hoped that this session was useful to you. Please press like. Please subscribe.